Hello children, we all are revising chapter number 10, light, reflection and refraction, and we are revising the questions which have been already asked in the previous year of CBSE board examination. Today we are going to discuss questions which are of 5 marks. So let's begin with that. This is the first question. State the law of refraction of light that defines the refractive index of a medium with respect to the other. Express this mathematically. And how is refractive index of any medium A with respect to medium B related to speed of propagation of light in two media A and B? State the name of this constant when one medium is vacuum or air. Next part of this question is a numerical. The refractive indices of glass and water with respect to vacuum are 3/2 and 4/3 respectively. If the speed of the light in glass is 2 × 10⁸ meter per second, find speed of light in vacuum and in water. You can observe that a 5-mark question is been divided into parts and every part is given marks. Let's begin writing the answer. First question is about writing the law of refraction of light, and we all are aware that this law is also called as Snell's law. So we can write it like this. When a ray of light of a particular color passing through a medium 1 is incident on another medium 2, the ratio of sine of angle of incidence to the sine of angle of refraction always remain constant, and this constant is called the refractive index of medium 2 with respect to medium 1, and it is denoted as N21. Alright, for writing this, 1 mark will be given. You have to express this mathematically, so it's easy. N21 is equal to sin I upon sin R. For writing this, half mark will be given. Next part of the sum, you have to write refractive index of medium A with respect to other medium B, which is denoted by NAB, in terms of or how it is related with speed of light in the media. So we can write it like this: NAB is equal to speed of light in medium B upon speed of light in medium A. If it would have been NBA, the ratio would have been exactly opposite. So children, this is very important. NAB is speed of light in medium B upon speed of light in medium A, and for writing this, 1 mark will be given. Next part of the question is, if medium B is a vacuum or air, then NAB is called as absolute refractive index of medium A, and it is simply written as NA. So NA is absolute refractive index of medium A. If I write NB, it will be absolute refractive index of medium B. And in terms of speed of light in air and vacuum, its formula will always be speed of light in vacuum upon speed of light in the medium. And for writing this, you will be given half mark. Next part of the question is a numerical, and for your reference, I have again copied the numerical here. And what we are given in the numerical is absolute refractive index of glass, which we can denote as Ng, is equal to 3/2. Absolute refractive index of water, Nw, that is 4/3. Speed of light in glass is also given to us, 2 × 10⁸ meter per second. What we have to find out is speed of light in vacuum and speed of light in water. So we will make use of the formula of absolute refractive index here. So we'll write absolute refractive index of glass is equal to speed of light in vacuum upon speed of light in glass. We are already given speed of light in glass and absolute refractive index of glass, so we can change our formula to find speed of light in vacuum. This is denoted by letter C. So our formula will be C is equal to Ng upon Vg. Substitute the values. 3/2 into 2 × 10⁸ meter per second. Cancel out this 2. We are left with 3 × 10⁸ meter per second, which is speed of light in vacuum. and for calculating this you will be given 1 mark. Let's now find out speed of light in water, and for that also we will make use of absolute refractive index of water. So NW is equal to C upon VW. Since we have to find out speed of light in water, so we need to change our formula. So our formula will be speed of light in water is equal to C upon NW. So let's substitute the values. 3 into 10 raised to 8 meter per second upon 4 by 3, and it will be 9 upon 4 into 10 raised to 8 meter per second, which is equal to 2.25 into 10 raised to 8 meter per second, and this is speed of light in water. For calculating this you will be given 1 mark. So this is how a 5-mark question is been divided into different parts, and accordingly marks are given. Let's move to the next question. One student uses a lens of focal length plus 50 centimeter and another of minus 50 centimeter. State the nature and find the power of each lens. Which of the two lenses will always give a virtual and diminished image irrespective of the position of the object? Now the key point is you should be aware that focal length of which lens is positive and which is negative. Then and only then you can answer this question. So we can write like this. The first lens of focal length plus 50 centimeter, it is a convex lens, and the second lens of focal length minus 50 centimeter is a concave lens. This is according to the sign convention. And for writing this you will be given 1 mark. Now you have to find out power of each lens, and for writing the formula of power of each lens you should be aware that focal length should always be in meter. So we need to convert this centimeter into meter. Let's write down power of lens. P1 is equal to 1 upon F1 in meter. Let's substitute the values. 1 upon 0.5 meter, that will give you plus 2 diopter. And for calculating this you will be given half mark. Then P2 is equal to 1 upon F2. Let's substitute the values. 1 upon minus 0.5 meter, that is minus 2 diopter, and for writing this you will be given another half mark. Last part of the question, that is which type of lens will always give you the virtual and diminished images irrespective of the position of the object. Children, we have seen the ray diagrams for both the lenses, and I'm sure you all are aware that it is a concave lens which always gives a virtual and diminished image which is irrespective of the position of the object, and for writing this another 1 mark will be given. So a 3-mark question is divided like this, and 3 marks are distributed in this manner. Alright, let's move to the next sum. The image of candle flame which is placed at a distance of 30 centimeter from a spherical lens is formed on a screen which is placed on the other side of the lens at a distance of 60 centimeter from optical center of the lens. Identify the type of lens and calculate its focal length. If the height of the image is 3 centimeter, find out height of the object. Very clear, children. Here the image is formed on the screen. That means it is a real image, and real images are formed by convex lens. So for writing this convex lens, 1 mark will be given to you. Let's write down what all is given in the given question. We have been given object distance minus 30 centimeter, image distance plus 60 centimeter, height of the object, that is H0, which is 3 centimeter. We need to find out the focal length and height of the image. So for finding the focal length, let's make use of mirror formula first. So 1 upon F is equal to 1 upon V minus 1 upon U. Substituting the values, 1 upon 60 minus 1 upon minus 30. So this minus minus will become plus. So let's have 60 as LCM and find out. 1 upon f is equal to 1 plus 2 upon 60, 3 by 60, which is equal to 1 upon 20. So f is equal to plus 20 centimeter, which is the focal length. And for calculating this, you will be given 2 marks. Next part of the question is to find the height of the image, and for finding height of the image we will make use of the magnification formula. And according to the magnification formula, M is equal to HI upon HO. I stand for image, O stand for object. So magnification is equal to height of image upon height of object, and this is related with image distance and object distance as V upon U. Since we have to find out height of the image, we will change our formula to HI is equal to HO, that is height of the object, into V upon U. Let's substitute these values because we have height of the object, we have image distance and object distance both. So plus 30 into plus 60 upon minus 30. Let's cancel this out. 30 2s are 60. So we are left with minus 6 centimeter, and so we can see an inverted image of the flame of the height minus 6 centimeter. And for calculating this, you will be given 2 marks. So this is how a 5-mark question is been divided into 2 plus 2 plus 1. Alright, let's see another question. Find the power of convex lens which forms a real and inverted image of magnification -1 of the object which is placed at a distance of 20 centimeter from its optical center. Now here magnification is -1. That means the image distance and object distance must be same. Alright. Now and the height of the image and height of the object should also be same. This is possible only when we keep the object at a distance of 2f. Alright. And therefore we can just write a convex lens forms an image of magnification -1 when the object is placed at 2f. So accordingly what we have, 2f is equal to 20 centimeter, and therefore we can find out focal length with this. F is 10 centimeter and 10 centimeter is equal to 0.1 meter. Now why I have converted this centimeter into meter? It's because when you write the formula for power of lens, focal length should always be in meters. So let's make use of the formula, but for finding focal length, you will be given 1 mark. So power of lens P is equal to 1 upon f. So 1 upon 0.1 diopter, and that is 10 diopter. And for calculating this, another 1 mark will be given to you. And this is how the question was asked for 2 marks in the exam. Alright children, so keep revising all the questions which we have taken in the 3 sessions. These are all very important questions, and you can get an idea about how the questions are asked. See you all in the next video lesson with the new chapter. Till then, bye and take care.